Hello, how are you?
Hello, I'm fine, thank you. How are you?
I'm also fine, thank you. Thanks for asking. Okay, so are we good to start the interview?
Yes, we can start the interview.
Okay. Can you tell me a little about your IT journey? How many years of experience you have, and a little about project architecture?
Yeah, so I have close to 4 years of experience and I have worked across various domains in that experience, starting from banking and finance domain to insurance and then to healthcare. And currently I'm working on telecom domain. So in that 4 years, I have worked across various things, Java, Spring Boot, microservices, and database. And I have seen various versions of all these. So my project currently uses a microservices architecture, and I know about backend. Backend includes Java 8, microservices architecture, Spring Boot 3, MySQL, and PostgreSQL database. So that is about overall architecture and things I know.
Okay, so when you say microservices, can you tell me what is API gateway in microservices?
Yeah. So first, we'll have to understand what are microservices. Microservices are small services and they communicate to each other using networks or using REST APIs. Okay. So when we have multiple services, so there should be an entry point to your application, and that entry point is API gateway. And the main benefit of API gateway is to route the request from your API gateway to the microservices. So consider there is an e-commerce application. There are three modules. There is a buyer module, there is a seller module, and there is a payment gateway module. And there is one more module, for example, notification module. Okay. So whenever the request is coming for payments module, so API gateway accepts the request and decide to which module the request should be routed. So API gateway is an entry point to your microservices application, and API gateway acts as a router of your request to a specific microservice. So that is about your API gateway. So Zool is one of the well-known API gateway.
Okay. And how do you authenticate the services?
Okay. So we authenticate the services. There are multiple mechanisms by which we can authenticate the services, but OpenID Connect or OAuth, these are the two things by which we can authenticate the microservices. So there's a when you there's something called as JWT, a JSON Web Token, and JSON Web Token has a specific payload. There's a header, there's a body, and there is a signature. Okay. So for each request, client has to pass on the JWT to the backend, and then we do the verification of JWT using the private key. And this JWT is used for authorization of the request. So we use JWT for the authorization of request in microservices.
Okay, and how your microservices communicate with each other?
Yeah. So microservices are generally small services. So to achieve one big goal, they have to communicate to each other, and the communication generally happens in two ways. The first one is asynchronous communication, and second one is synchronous communication. So let's try to understand both of these. So in synchronous communication, we generally use the REST API call. So consider there is microservice one and there is microservice two, and they want to communicate with each other. Then microservice one calls one of the API endpoint of microservice 2. And this is generally a REST call, representational state transfer. So why it is called synchronous? Because when microservice A calls microservice B, then the first service has to wait for the reply from the second service. So until that, it cannot proceed further. It cannot proceed further. Okay. So this is synchronous communication. And in case of asynchronous communication, we use a message broker or an event broker, like RabbitMQ or Kafka. Okay. So for synchronous communication, we use REST APIs, and for asynchronous communication, we use RabbitMQ or Kafka. Okay. So all right. So we have recently launched one-to-one mentorship and interview preparation kit for our students. So if you want to register, you can do WhatsApp on the number that is shown on the screen. So here is a basic overview of roadmap that we are going to use for preparing you for the interviews. So we are going to cover three important topics. One is microservices, the other one is Spring Boot and the Java. And we are going to cover all the things that you require to nail the interview. So let's go through the roadmap. We are going to give the link in the description as well. You can go through the roadmap personally. But at a very high level, we are going to cover what are microservices, what are the benefits, how microservices differ from monolithic application. Okay, how do microservices communicate with each other, how to build resilient microservices, how to achieve authentication and authorization in microservices, what is circuit breaker. So you can go through a holistic a roadmap. We are going to give the GitHub link, and then we are also going to give you the Spring Boot training. So this will cover all the common questions that are asked in the interview. What is Spring Boot application? How to create one Spring Boot application? What are the different annotations? What is auto wiring? How to build a CRUD application, so on and so forth, how to secure your application, what is Spring Data JPA. So week-wise, we have given all the roadmap. And finally, we are going to cover core Java interview questions, whatever are required for your interview preparation. So for any further inquiry, just go to the WhatsApp number, just message or do a call. So that is about the mentorship and interview preparation.
Okay, great. Now you said that you are using microservices architecture. So let us consider there are three services in your architecture or application. One is service is trying to call to other service and that service is calling to a third service. Now let us consider service A wants to communicate to service with service B and service B wants to communicate with service C. But due to some reason, service C is not working as expected. Okay. So how do you handle these failures?
All right, so this is a common example of cascading failures. The service one is calling service two, service two is calling service three, but service three is not performing well, or it is failing, or it is very slow, whatever the case might be. Okay. Now, in this case, we try to use something called a circuit breaker. Okay. So now, when service two is trying to call service three, and it calls service three for 5 times, and suppose we are getting a failure, we are making request one, we got failure, we are making request two, we got failure. For the third request, we are not going to make any further request to service three. What we are going to do, we are going to break the circuit. So service two is no more going to call service three until service three is recovered. Okay, so we are going to give some chance to service three to recover itself. Okay, and after some time, and this time is decided by a developer, after some time, what we will do, we'll make some more requests to service three just to understand if it is performing well. And if the service three is replying well and calls are succeeding, then we are going to make further calls to service three. So this is known as a circuit breaker pattern, and we achieve resiliency using a circuit breaker. Okay, so there is a framework known as Resilience 4J. We use this framework to achieve this mechanism.
Okay, great. Now you mentioned that one of the API can be slow. So let us consider I need to optimize that API. So what are the things which I need to check to optimize the performance of a particular API?
Yeah. All right. So this is a very important question, and so many of times what happens, your one of your microservices becomes really slow, and this can be due to multiple reasons. So the first reason is that you are doing some database operations. Okay, and this database operations, the query that you are firing, the query itself is very slow because you don't have indexes on the columns which you have used in the where class. So the first important step is to put indexes on columns which you are using for filtering. Okay, so checking for the indexes is the first thing. And the second thing is you have the application running, okay, that is on the server, and you have a database on a different server, and there is a latency between your application server and your database server. So these calls are very slow and sluggish due to some reason. So you have to keep your database and your application server close to each other in your cloud infrastructure or in your on-premises infrastructure. The third thing that can happen is you are not doing authorization well. For every request, you are reaching out to your authorization server using their authorization API. So you have to do all the authorization related activity in your applications itself using verification mechanism rather than reaching out to your authorization server. Okay, so these are a few things which you can optimize. And there's one more thing. Don't bring in all the data in your CPU. Do all the filtering logic in your database, and then bring only the relevant data that you require for processing in your CPU or in your RAM or memory. Okay, these are few things which you can take care of in your. And one last thing, if your database itself, the structure of database is not correct, then you can go ahead and try to optimize the schema of your database itself. So these are few things you can go ahead with and check.
Okay. So can I use caching here? Do you know what is meant by caching?
Yeah, so correct. You can use caching also. Caching also is one of the performance steps that you can do. So there are few requests where the response is common. For example, if I hit that request multiple times, if I hit that request 10 times, then I get the same response each time. So for such request where the response is not changing too much, too frequently, what we can do, we can use caching mechanism. Okay. So what does cache do? Whenever there is a request for the first time, we hit the database, we bring on the response, and then we cache that response in memory. Okay. And for any further request or for any subsequent request, we don't go to a database. We just check in the cache first, and we send back the response to the user of the request. Okay. So what happens? If we are not hitting the database every time, then this making a connection to the database, all these things are not required, and the load on your database is reduced. So that is why we use caching. There are various types of caches like Redis and Memcache, and the decision depends upon your use case. Again, there's one more step which you can perform. Generally, while connecting to the database, what happens? We try to make a connection. So if you want to optimize your API, you can build a connection pool. So connection pool is a set of connections, database connection, which are ready-made. So you don't have to create connection from scratch. There is a pool of 10 connection, for example. And whenever you want to hit a database, you pick one of the ready-made connection from the pool and then hit the database. So this is also one of the steps for your optimization.
Okay. Now, can you tell me how do you build these services? So you are using Spring Boot, right? So can you tell me the steps which will be required to build a service from the scratch?
Yes. Okay. All right. So the first step is selecting a JDK. What version of JDK do you want? So first step is either Java 17 or Java 21, depending upon your requirement. So you select the JDK. The next step is to build the Spring Boot application. So there's something called as Spring Initializer. So you go to Spring Initializer, there's a website. Uh, and after going to Spring Initializer, what you do, you try to select the version of Spring Boot you want, okay, and the version of JDK you want, and how you want to build your application. If you want to build your application through Maven or through Gradle, it gives an option to select one of them. Okay. After doing all this, then you select the dependencies. Okay, suppose if you want to build REST APIs, then you use Spring Boot Starter Web or whatever starter dependencies you want to select. You can go and select those dependencies. And finally, you download your application. And when you download your application, you get the application in the zip format. Then you unzip that application and import that application into IDE, Integrated Development Environment of your choice. So there is Eclipse, there is IntelliJ, and there are many more. Okay. So companies generally prefer either IntelliJ or Eclipse, depending on the criteria they have. You import that thing into your IntelliJ, and then you start working. So when you download and import it into your IntelliJ, so the first thing is your class, your main class from where the Spring Boot application starts. It is annotated with @ Spring Boot application. Okay. And you start that application, and that application is started in the embedded Tomcat. Okay. And then you can that application can serve your user on a specific URL. For example, localhost colon 8080 and slash whatever APIs you're hitting. This is how you create the application, you download the application, and you import the application in your IDE.
Okay, so you mentioned at direct Spring Boot application annotation. Can you tell me what is the use of that annotation?
Yeah, so this annotation is a combination of multiple annotation, but I'll give you the use of it at a very high level. Okay, so it does a few things. The first thing is it scans for your components. Okay, using @component scan. It is a combination of few annotation. So component scan. What is a component? Any bean or any service, any repository is a component. A component is a generic stereotype for all these things. So if you want to have a service, if you want to have a repository, or if you want to have any other thing, then you mark that class with @component. So when you have @Spring Boot application annotation on your main class, so it scans for all the components that are present in your application. Or that is the first thing it do. It scans for all the configuration that you have in your application. So apart from component, there is something called as configuration. So to combine all this functionality into one annotation, Spring Boot came up with Spring Boot application annotation. So it is used for starting up your application.
Okay, and how do you package your classes? Can you tell me a little about your structure or packaging structure in your application?
Yeah. So we have three layers in my Spring Boot application. The first layer is a controller layer, and controller layer is where all the request lands in your application. So from controller layer, we have a service layer. We generally have calls from controller layer to our service layer. And service layer contains all the business logic of your application, whatever business logic or whatever use cases you want to implement reside in your services. And from services, we call the repository. So repository, the responsibility of repository is to perform the CRUD operation, create, read, update, and delete. So repository is the only one which is going to interact with the database. Okay. So generally we put all the controller in the controller package and services in the service package and repository in the repository package. And there is a clear separation of what each one can do. The controller generally all the request related things, extraction of the variables from the request, extraction of the body, all these things are performed in the controller. For your business logic, everything is performed in your services. So whatever business logic you have, you have to write it in your service. Whatever transactions you have to start in your service. And all the database related activities you have to perform in your repository. So this is how the application is structured in the Spring Boot world.
Okay, so you must be connecting with the database, right? So what are the properties which will be required to connect with the database, and where do you mention these properties?
Right. So there are multiple properties, but every time you try to connect to a database, you mention properties in your application.properties file or application.yaml file. Okay. What you have to mention, you have to give the server where your database is running and at what port your database is running. Okay, so this is related to host and port. Then you have to you have to give the username and the password by which you want to connect to your database in your application.properties. And by when you start up your application, Spring Boot, what it does, it creates a data source using all these properties and it makes connections to your database. So you need application.properties with your server at which database is running, port at which the database is running, and the username and password to connect to your database. And then these all things you have to mention in your application properties or application.yaml.
Okay, now let us consider there are certain other properties which I would like to read into my Java code. So how can I do that?
Okay, so there is something called as there is one annotation @value. You can use @value and you can give the property name to this @value using dollar symbol, and that you can read in your application from your application.properties file using @value annotation. Okay, and if you want to have if you want to configure your application differently for different environments, then you can use profile. You can create multiple profiles using dev for dev, for QA, and for UAT. And while starting up the application, you can give the profile name by which you want to start the application. So you can create the beans differently or connect to a different database using different profiles.
Okay, great. On Java side, which version of JDK you are using?
So we are using Java 17, but we are also using a lot of features of Java 8.
Okay, can you tell me a few features which are available in Java 8?
So Java 8, before Java 8, there wasn't Lambda expression or there wasn't functional programming. So after Java 8, we are using functional interfaces. We are using Lambda expression. We are using streams. We are doing a lot of things using streams. So we have converted all our code prior to Java 7, and we have taken all the code and we have converted it into Java 8 using streams, functional interfaces, Lambda expression. And there are date APIs, which we generally don't use. And there is something called a string joiner, which we are using a lot in our application.
Okay, let us consider there are certain numbers. Let us say there is a list of numbers which I would like to filter. Okay, so I just need to find out the even numbers from that list. Can you just tell me how can I do that using Stream APIs?
Yeah. Okay. So you have a list of numbers and you are interested only in the even numbers. So first thing, I'll take a list dot stream. For performing any operation in Java 8, you have to extract a stream out of it. Once you get the stream, stream is what you will get each element from the list one by one. Okay. Then after getting stream, you can perform standard operation. So another operation is filter. So I do filter, and in filtering, I get every number from your list. Okay, now it's my duty to filter the number which I even. So I am going to use the logic. Uh, I'm going to do I mod 2 equal to 0. If any number modulus 2, if the remainder is 0, then that number is even. And once I do filtering, I'm going to collect. So I'm going to call dot collect method, and I'm going to collect this into a list. So collectors dot to list. You can collect it into a set or any other data structure you want. But generally, the structure is like this. Take out stream out of your data structure, do operations, either terminal operation or intermediate operation like filter, and then finally collect. So once you collect, you get this thing into a separate list. So that is how we are going to perform. We are going to filter even numbers.
Okay, great. And how do you handle exceptions in Java?
Yeah, your voice is not audible.
So I was saying that how do you handle exceptions in Java?
Okay, so uh, we handle exceptions using try block, catch block, and finally block. So these are the three constructs which we use for handling exceptions. So whatever code we think might produce an exception, we write that code into a try block. Okay, and whenever there is an exception in the try block, the control is passed to a catch block, and we do exception handling mechanism in the catch block. And after this, there is something called as finally block. Finally block is where this block is executed every time, whether there is exception or if there is no exception. So it is almost always guaranteed that finally block will be executed. There are few cases where finally block is not executed, but in normal circumstances, finally block is always executed. So we handle exceptions using try, catch, and finally block.
Okay, okay, fine. I'm done from my side. Do you have any questions for me?
No, I don't have any questions. Thank you. Thanks for the interview.
Yeah, thank you. Bye.